Welcome to The Explainer. Today, we're diving into a fundamental clash in the world of computing. We're talking about the universal standard versus the specialized tool, and we're going to tell that story through two really powerful ARM architectures.
So let's frame the big question right up front. Is it better to have one universal standard that just works everywhere? Or is it better to have a highly specialized tool that completely dominates its own niche? This is the core conflict we're exploring today, especially when we look at ARM servers and the world of Edge AI.
All right, first up, let's talk about one side of the story, the drive for order, for consistency, for standardization. And that idea is perfectly embodied by something called the Server-Based System Architecture, or SBSA for short.
Now, here's the most important thing to get right off the bat. You can't go out and buy an SBSA. It's not a physical thing. Think of it more like a blueprint or a foundational agreement between hardware makers. Its whole reason for being was to solve this massive historic problem in the ARM world called fragmentation, where basically every single device needed its own custom-built operating system. SBSA fixes that. It says, hey, if you follow these rules, one standard OS image can run on a whole bunch of different servers.
And this slide really breaks down what those rules actually cover. Things that sound technical but are absolutely essential. Take the interrupt controller. That's just how a piece of hardware gets the CPU's attention. By making it standard, the OS doesn't need a special driver for every machine. Same thing with firmware like UEFI. It standardizes how a computer boots up. It's all about creating a predictable, stable target for the software to run on, basically taming the Wild West of custom hardware.
But here's the really clever part. SBSA isn't stuck in time, it evolves. It uses these different levels to create a clear roadmap for the entire industry. An OS developer can say, hey, our next version is going to require level 5 features, and all the hardware makers know exactly what they need to build. It's a brilliant way for the standard to get better and adopt new features over time without breaking everything that came before it.
Okay, so we've seen the champion of order. Now, let's meet the challenger. We are shifting gears completely from a world of universal rules to a world of raw, focused, specialized power. Let's talk about NVIDIA's Jetson platform.
And right away, the difference is huge. Unlike SBSA, which is a blueprint, a Jetson is a real thing you can hold in your hand. It's basically a mini supercomputer. The key components of an entire system are all fused together onto a single chip, and it's built for one main purpose: to run AI tasks out in the real world, in things like drones, cameras, and robots.
And this is where you really see the different philosophies at play. A Jetson isn't just a CPU. No, it's what we call a heterogeneous architecture. Think of it like a team of specialists all working together on one chip. You've got the ARM CPU to run the operating system and do general tasks, but the really heavy lifting is offloaded to the other guys. The GPU handles massive parallel math, and those deep learning accelerators, they're purpose-built to do one thing: run neural network calculations, and to do it with incredible efficiency.
This idea of vertical integration is absolutely critical to understanding Jetson. The hardware and the software are designed together, hand in glove, for maximum performance. To really unlock what a Jetson can do, you use NVIDIA's software stack: Jetpack, CUDA, TensorRT. Now, that does mean you're playing in NVIDIA's garden, using their tools. But the trade-off is that you get this incredible, deeply optimized performance that's hard to achieve otherwise.
Okay, so we've met our two contenders. On one side, we have the Universal Rulebook, SBSA. On the other, the specialized AI powerhouse, Jetson. Let's put them in the ring, head-to-head, and really see where their core philosophies clash.
When you boil it all down, they're just trying to do completely different things. The goal of SBSA is to create a universal, flexible platform. A server that can run a website, a database, a cloud application, anything, just like the x86 world. Jetson, on the other hand, is a purpose-built weapon. It is designed to win the AI fight at the edge, where performance per watt on very specific tasks is the only thing that matters.
And that split? It defines their entire world. SBSA creates what's called a horizontal ecosystem. It's a broad, open playing field. You can buy a CPU from one company, a motherboard from another, and run an OS from a third. It's all about choice. Jetson is the opposite. It's a vertical ecosystem. It's a curated, high-performance walled garden, where NVIDIA controls the whole stack, the chip, the software, everything, to promise that it all just works together perfectly.
And wow, look at the difference when it comes to power. This really tells the story, doesn't it? A big, powerful SBSA server CPU is designed for a data center with massive cooling. It can easily pull 200 watts of power.
But then you look at a top-of-the-line Jetson module. It's delivering incredible AI horsepower while sipping only around 50 watts. That's why you can put it in a battery-powered robot or a drone.
Okay, so it seems like we have this classic battle, right? The generalist versus the specialist. Standardization versus specialization. But what if it's not a fight to the death? What if these two very different worlds are about to collide in a really, really interesting way?
And that leads to this fascinating question. Historically, if you'd asked this, the answer would have been a hard no. Absolutely not. Jetsons always used custom bootloaders, custom firmware. You pretty much had to use NVIDIA's specific software to get them to even turn on. There was no way a generic server OS was going to run on one. But something's changing.
Because now, the answer is yes. This is the big twist in our story. NVIDIA's newest, most powerful Jetson ever, a beast of a chip called Thor, is being deliberately designed to be SBSA compliant. They are actively merging these two worlds, creating a single product that is both a specialized AI powerhouse and a standards compliant system.
So you've got to ask, why now? What changed? Well, it's really a sign that the whole market is maturing. As these edge devices, we're talking advanced robotics, autonomous cars, as they become powerful enough to run truly enterprise-level AI, their customers start demanding enterprise-level features. They want reliability, they want security, they want easy management. In short, they want standards. Jetson is growing up.
And I really want to stress this point. This is not just some minor feature update. This is a huge deal. The amount of engineering effort it takes to do this is massive, and it signals a major evolution for the entire edge computing market. It means we might be getting the best of both worlds, insane specialized performance built on a reliable standard foundation.
So the story of Jetson and SBSA converging like this suggests that maybe the ultimate winner isn't one philosophy or the other. Maybe it's a powerful combination of both. And it leaves us with a really fascinating question to think about. Are we heading towards a future where all of our most powerful, most specialized computing tools are all built on top of a common, universal bedrock of open standards? The answer to that is going to define the next generation of computing.